So I said I was going to put in an ice table. So the I stands for initial concentration, C stands for change, and then E stands for equilibrium concentration. So I have to put in each thing what it is. So for the ethane, oh my goodness, acetic, whatever it's called, that thing, I'm writing down the initial, the change would be negative x, so then the equilibrium would be 0.02 minus x, and then for H2O I don't add it in because the concentration can't change for a liquid or a solid because all the particles within that substance is like unified and can't change. Then I would put in for the H3O, and there's no concentration in the initial, and there's none for the base at the end. It would be positive x for the H3O, and then positive x for the base. So that means that the equilibrium concentration would just be x and x for both of them. Oh, I can't show you that. And then after, what I have to do is put everything into the equation. So basically the equilibrium constant equation thing, I would do Ka equals 1.8 times 10 to the power negative 5. So I substituted for that. And then it would equal, put the products at the top, so x, so x squared, all over the reactants, which is just 0.02 minus x, it's just the base. And then basically what you would have to do after, you would do 1.8 times 10 to the power negative 5 equals x squared, all over 0.02 minus x. And then after you would get the denominator, bring it to the other side, so 0.02 minus x times 1.8 times 10 to the power negative 5 equals x squared. And then what I would do is just do quadratic formula, I think. That's what I'm going to do. And I'll bring everything to that side. So 0 equals x squared plus 1.8 times 10 to the power of negative 5x minus 3.6 times 10 to the power of negative 7. And then I'll do quadratic formula. So x equals negative b, so 1.8 times 10 to the power of negative 5 plus or minus square root b 1.8 times 10 to the power of negative 5. Minus 4, 1, negative 3.6 times 10 to the power of negative 7, all over 2a, so 2 times 1. So then let's just put that in the calculator. X equals negative 1.8 times 10 to the power of negative 5 plus or minus. Oh, wait. B squared. So 1.8 times 10 to the power negative 5 squared. Oh wait, I want to... So it's 3.24 times 10 to the power negative 10 minus negative 3.6 times 10 to the power negative 7, 3.6 times 1 is that, times negative 4 equals plus 1.44 times 10 to the power negative 6, and then I'll add the 3.2 times 10 to the power of negative 10. Oh, I should add brackets. Do I have to go back and do it all over again? Do you know what? Yeah, I'll just do it because I need to add brackets. 1.44 times 10 to the power of negative 6 plus 3.24 times 10 to the power of negative 10 equals square root 1.44 times 10 to the power of negative. Answer. So it'd be negative 1.8 times 10 to the power of negative 5 plus minus 1.2001, so just 1.2 times 10 to the power of negative 3 all over 2. So then I'll add, for the first one, negative 1.8 times 10 to the power of negative 5 divided by 2, which equals 5.9 times 10 to the power of negative 4, or it could equal negative 1.8 times 10 to the power of negative 5 minus 1.2 times 10 to the power of negative 3 divided by 2. Can't have a negative number, so it equals 5.9 times 10 to the power of 4, negative 4 moles/liters. Perfect, that's the answer.